Hi, this is Mike at Gamefromscratch, and today we're going to be looking at dealing with input in LibGDX. Input basically means mouse, keyboard, and touch. We're only going to touch on the basics here, so we're not going to be dealing with gestures or multi-touch, anything like that. Pretty much when in a game, there's two ways of dealing with input. One is to poll it, which is to say, is there anything happening? Is there anything happening? Is there anything happening? Deal with it accordingly. Otherwise, you can have it event-driven, where if something occurs, it pushes it to your application. We're actually going to look at both examples. Let's jump right in with the first one, and we'll start with polling. It's a little bit simpler. Let me just open up my project here. All right. Now, one of the first things you're going to have to do when loading up a project in IntelliJ anyways is to configure your Android project to use the Android SDK. So I'll just go ahead and do that quickly. You can also just hit F4, and all you have to do is come in here, pop, and turn that to Android. All right. So now we're ready to get started. Let's go into our code right away. We're just going to use the asset that comes with it, which is, once again, if you've got an Android project, assets go in the Android folder. We're just going to use the default Bad Logic logo for this one. We're going to be moving around the screen using a combination of controls. First off, again, like I said, we're going to deal with polling input. So let's start our code up. The first thing we want to do is create a sprite. And I'll get you into station mode, make this a little bit easier to see. All right. So let's create a sprite. So, and allocate it using our default texture. So, and then we'll position it. Once again, centered. Oops. Like so. All right. And come down here. Instead of our image, we'll use our sprite. And we will change to use our sprite's coordinates. If none of this looks familiar, you should really look at the last tutorial. We covered all this in the past, so I'm not going to go through anything I've covered in previous videos. So if you want to look at dealing with a sprite, look at the last tutorial in this series, and it covers it completely. So there you go. We got the drawing going for a sprite we've created. There is one thing, however, that I did not cover, and I really should have. So I'm gonna address it very quickly here. And that is disposing of things. One of those things that people who are working with Java thinks is that you can't have direct access to memory. Well, that's not entirely true. Behind the scenes, there's a bunch of C code, C++ code that is native, and you don't automatically get rid of the memory when you're done. Now, in these simple examples, we basically run and then exited. So memory leak doesn't really mean anything because it's going to leak at the point your program ends. However, you should get in the habit of cleaning up after yourself. One of the things that actually needs disposing is the texture class. To get rid of stuff, generally what you do is you implement the dispose, like so. And in it, all you do is simply dispose of your class, like so. Now, key way to find out if a class is or is not native, if you have to get rid of the memory or not, is does it implement the dispose interface? That comes from iDisposable, and if you go over to the website, here's the documentation for LibGDX. You can see right here, disposable is a base class, and these are the classes that implement it. So if we look through here, we should see that there's our texture. You'll notice, however, a sprite is not disposable. So our sprite batch should be disposed of, our texture should be disposed of. So more or less, if it has a dispose call, when you're done with it, you should call that. Otherwise, you are actually leaking memory. Again, when your program finishes execution, all that memory is going to be freed anyways. But for things that are like allocated and deallocated, allocated, deallocated, you've got to make sure you call dispose or you will leak memory. So that's a just quick thing to be aware of. Now let's go ahead and we'll run our project. It's an Android application. Sorry, it's a desktop application. So we go through here, grab our module, go desktop, change our assets folder. So in this case, we have an Android project created. So we want the Android's assets. Otherwise, it's the core's assets. And we set to the desktop launcher. So I'll go ahead and run that. Okay. first build slightly slower. And there you go, center to the middle of the screen. There's our graphic being drawn. Now let's go ahead and control it with the keyboard. First thing I'm going to do is get rid of that god-awful red color. So let's turn that back into black. So how are we going to handle input? When polling, what you're going to do is say, has there been any input? And LibGDX actually makes this incredibly easy. Let's, at the top of our render method here, let's get this gone so we've got more room. At the top of our render member here, we're just going to do a simple if, and we're going to check gdx.input.isKeyPressed. And then there's an enum of key values already set for you in the LibGDX library, and that's under input.keys, and then you just pick input.keys. Now, I don't know why it went wrong there. Left. So this is if someone presses the left arrow, we're going to do this code, and we'll just translate our sprite along the x-axis -1. And at the same time, if the user hits right, we'll translate in the opposite direction, like so. All right, so there's our very first input. Let's go ahead and now run our code. And if I hit the left arrow, hold down the left arrow, that's key. So you can either tap it and it moves once, or you can hold it down and it continues to move. Remember that for later on. And that's how you do it. So there's very simple input polling of the keyboard. Same way you can do for the same thing for the mouse. So very similar process, input dot, and then you can see pretty much all of your keys all of your input devices have an approach this way. The accelerometer for motion, and so on and so forth. Roll pitch for moving your device around. But in this case, we just want to do get X and get Y. Get X and get Y are going to be generic, so it works the same for the mouse or touch. However, get X for passing in a pointer. Pointer is thought of as finger. So you could say get X2, and that will give you the X position of the third finger touching the screen, because remember it's a zero-based array. But let's just go with normal get X. Oh, actually, that's not what we want to do at all. Sorry, my bad. We want to check to see if the user presses the button. Is button pressed? All right, so input, bet you can guess this one, buttons dot, and we'll do it on the left click, and if they are, we'll position the sprite at that location. Here, let me cut and paste coder. You're about to see something kind of screwy. So there it is. So now whenever we left click, it should automatically draw the sprite wherever we click. However, it's not going to. Yes, that's a bit of a spoiler. So left. Okay, it's not doing anything at all. 1 second. Okay, that was kind of stupid of me. What we want to do is set it to the actual the cursor location where the mouse is currently pressing. So in that case, we just want to do gdx.input.getx, gdx.input.getY. My bad. All right. So now when we run that, wherever we move the mouse, in theory, the graphic will go. In reality, that's not what's going to happen. All right, I'm having trouble with my brain here. So it's where you click. Now, you might notice it's not doing that at all. And the reason is the mouse coordinates that you're being passed, or the touch coordinates you're being passed, are being passed in UI coordinates. Welcome to the wide world of game programming. You have multiple coordinate systems, and it gets very annoying. I mentioned earlier on when we did the graphics work that the origin in LibGDX is the bottom left corner. So when you say draw something at 0, 0, it's right here. However, for UI coordinates, 0, 0 actually represents here. That means when Android or Windows or whatever are passing in the coordinates where your mouse is, they do it relative to the top left corner of the screen. And you have to account accordingly. There's two ways to go about that. One is to use a camera and unproject it. We'll cover on that a little bit later, but if you want, just Google camera unproject mouse LibGDX, and you should probably find some documentation getting you there, but we will cover that eventually. There is also an easy mathematical way of doing this, and we're just going to change our code slightly. And instead of drawing wherever the Y cursor is, we just want to subtract out our height. So gdx.graphics.getHeight. There. And this will now make our coordinate relative the same coordinate space as our graphics. So the bottom left corner is where it draws. There you go. So that's the very basics of implementing hold-based input. So this responds more or less, you're checking every loop, even if you don't want to, even if no input's occurring, you are checking to see if it occurs. And you're using a number of globals that are available in libgdx, the gdx.input stuff, to poll if it's available. And it's very consistent. It's the same basic logic for motion controls and so on. There's also the option of responding via event-driven. Now let's take a look at that. Let me just see, close this guy out. Exit presentation mode. All right, so we'll close this project and let's start a new one. Okay, so now we're going to do event-driven input. Open up our project here and let's get straight to our code. Again, we're starting from scratch from the basic template, so right away I will get rid of that awful red. There we go. So, add our sprite, allocate our sprite, position our sprite, and switch out our drawing so it's using the sprite instead of just the texture. All right. And I'll go ahead and configure our Android so it's using the Android SDK. Unfortunately, something about the project in IntelliJ, you always have to do that step if you make an Android project. There we go. So we're now ready to run. I need to create simple Android application, sorry, a normal application. Go through here. Jules Desktop. This should become second nature to you by now. Let's see, event, Android, assets, all right, and desktop launcher. Okay, now go ahead and run that. You're going to notice the initial pause here is actually this predex running. Predex is the process that Android uses to, Android isn't really Java, it's Java-like. So when you're running Java code on Android, it's actually being converted, and that process is called predex. So when you see predex running, it means it's building your Java application, but it's basically transpiling the Java code to Android-compatible code. So anyways, there we go. Our program is now running. Here you go. Now let's go ahead and add some event to it. This is done using an interface, actually. So we go to our application adapter, which are our main application, and we now add an implement. And what we want to implement is something called event processor. Or sorry, input processor. Input processor is exactly what that is. It says that my application handles inputs. And both Eclipse and IntelliJ have the ability to auto-implement methods, so let's go ahead and do it. We have to implement them all, so let's just let it happen. And you'll see it's added a number of events here for like key down, key up, key typed, touch down, touch up, touch dragged, mouse moved, scrolled. Scrolled is just your straight your mouse scroll wheel. Now let's go ahead and implement what we just did. We're just going to move left whenever the user touches the key. Now what you'll see here is we've actually got key down, key up, and key typed now instead of what we had earlier, which was is key pressed. So the way you're going to go about dealing with things is a little bit different here. This is happening as it happens. So when you press the key down event is fired. When you press the key up event is fired. There's no concept of is a key pressed here. Oh, and key typed is basically the whole down and up. Now, what we want to do here is on key down, we're just going to go ahead and update our sprite position. And this is probably not going to do exactly what you want to do. Actually, we'll translate it. by -1f. So we're going to move left by 1 pixel whenever the, oops, I suppose I should put an if condition here. Key code equals input.keys. You're doing it to me again. There we go. Left. All right. Pretty that up a bit. So there we go. We run this code. When we hit the left arrow, nothing happens. That's because I forgot to do something. When you implement the input processor, it's not enough to actually just implement it. You also have to register it. So that means at the bottom of your create function here, just call gdx.input.setInputProcessor, and you're setting in this class. You could also make the input processor a child class and have all your input handled that way, or a derived class or such. But in this case, we're implementing it directly in our application class. So what we have to do is register the input processor here. You can actually multiplex them. So you can have multiple input processors going at the same time. And that's something we'll cover later on. So once you've registered as an input processor, make sure you call setInputProcessor at the end of your create function. And now it will start receiving events. So let's go ahead and run it. And when I hit the left arrow, we move. Now let me show you something. I'm going to hold down the left arrow, and it responds exactly once. This is because there's actually only ever one event set. And when I let go of the key, it's going to send me the other event for the key up, and that's it. So if you want to have logic of holding down, holding up, you actually have to do it yourself. It's quite simple to do. Or you could actually, of course, mix a little bit of event and polling if you wanted to. But you can do it with a simple flag. Right equals false, and then we'll go back here and we'll add some logic for if key code equals input.keys.right. What we want to do is change the flag there to moving right is true, and when the key is released or key up, we're going to go to, oops, if key code equals input keys dot right, moving right equals false. Don't know why you're not liking that. What did I set? Oh, sorry. My bad. I work in many different languages. I'm used to just bool. All right, so now it's set, and then in our render, we will just add a little bit of logic. Say if moving right, sprite.translate x, and then we'll just go with 1 to the right. So now when I run this, again, the left key. Each time you press it, it moves, 1 press, 1 pixel. Now if I press right and hold it down, it will move slowly and smoothly, and then I let go, and it's done. So that's one of the major differences when you're dealing with polled input versus event-driven. In this case, where you're using an input processor and it's sending it to you, there is no concept of state for keys down. So you are in charge of tracking that yourself. As you can see, it's fairly simple to do so. So depending on which way you want to go, you can implement things pretty much either way. Now we're going to look over here quickly at the mouse move. Mouse move is going to be the same thing. Here's where input-driven shines versus polled, because what you're getting is every single frame, you're getting an update of where the mouse is. So we can simply come in here and go sprite.setPosition, and then we'll set it to screen X and screen Y. Screen Y is, once again, the coordinate's going to be the top left. So what you're going to want to do is go get height minus, like so. And we'll run this code. And now as you move the mouse around, you will see it moving in real time. So this is one of those things that polling doesn't do well. So unless you poll every single frame for its location, update accordingly, whereas if it's pushed or event-driven like this, you can easily implement constant movement changes. Again, which way you decide to go, it doesn't really matter. Processing power-wise, you're kind of getting about the same thing. Event-driven is probably, like using the input processor is probably slightly more, it's better use of performance, probably slightly less battery drain, etc. But for the most part, it's such a minimal amount of difference that it's not going to really make a big difference which one you choose. So that's that. The one last thing two last things actually I'm going to talk about. This one I can't show you, unfortunately, because I haven't figured out a way to mirror my device on screen, and you can't do multi-touch using the emulator. So this one actually needs to be run on your Android device in order to see it. But this is the exact same thing as mouse move, except for with the finger down. So touch down is when you touch down on the screen, it gives you the position where you touch down. Touch up is again like same as mouse up or key up. That's when you let go. That event is fired. And touch drag is a touch down and a move combined. Now the key thing in every one of these cases is pointer. Pointer is, again, a zero-based index for your finger. So the first finger to touch the screen is 0. The next finger to touch the screen is 1. The next finger to touch the screen is 2, and so on and so forth. However, as you start releasing fingers, the index stay the same. So it's until you let go of, say, the second. So what you're going to have is touch with 3 fingers, remove the second finger. The third one's index is still going to remain 2. It's not going to become 1. Does that make sense? Hopefully that does. So pointer is going to be the relative offset. It's the finger based off of 0 offset. You may also notice at the end of touch up and touch down, there's this value for button. And that may not make sense at all at first, but the reality is what they've done is they've made mouse events masquerade as touch events. So you don't really have to handle, there is no button down on the input listener like we had before. Instead, it's sent as a touch event. So right mouse button clicked is going to be a touch down with the button value set to left button. Touch up is when you release the button. So what they've done is they've packed in input handling and mouse handling and touch handling into the same 3 events. However, there is no concept of a mouse moved with touch because you need to be physically touching the device. The closest you've got, of course, is touch dragged. So that's how you handle the mouse when it comes to touch events too. You basically treat them all the same, just instead of using the pointer value, you use the button value to figure out what, if any, buttons are down. Finally, you've got the scrolled value, and this is just your scroll wheel. It's very simply controlled. If the value is, so let's do a very quick example. If amount is greater than 0, sprite dot translate y 1f, and if is less than 0, sprite dot translate y negative 1f. All right, so let's go ahead and run that. And okay, so I still have that mouse moving there, so I'm gonna have to stop moving my mouse. And as I scroll it now, scroll down without moving the mouse, it pans up, and then scroll up, it pans down. Probably easier to see if I go ahead and take this call out, like so. So that's how scrolling works. Yeah, that's basically the gist of input. So when you're dealing with event-driven input, you implement an input processor, you register the input processor to whatever class you registered as, in this case, since it's this, and then finally you just implement the methods that are required. Mouse and keyboard are encapsulated to be the same basic event, just handle either pointer or button, and that's about it. The only thing I'm going to keep aware of is there is no state like there is with the is down type functions, so you can track it yourself, or you can use the polling based input that's available in LibGDX. So that's the basics of dealing with input. I hope that was useful. Thank you.